Thanks. Welcome, everyone. I'm your cute KDE guy at this conference. Also my first one. Very excited so far. And I have many hats on. In my free time, I contribute a lot to KDE, big open source project using Qt. I maintain the kdevelop IDE. If any one of you uses that, please drop by. Tell me what you think about that. I work at KDAP, a consultancy company in the Qt ecosphere and C++ in general. But yeah, today I want to talk about Heaptrack. Who of you uses Massive or has used Massive for heap profiling? So a few of you. I hope you have used my visualization tool to actually interpret the results there. I did that tool 5 years ago, so to actually figure out where your memory is being used in your application. Very useful, got super good feedback about the visualization part there. But I had a big issue with it. It's super slow, especially because Valgrind synchronizes parallel code. It easily leads to an overhead of 100 plus or something like 100 times it or something like that, or even more. And I always thought, shouldn't it be possible to get something faster? And while at it, couldn't we collect more data? Massive only gives you like, okay, this function allocated this and that amount of memory, but it is not able to tell you, wait a minute, you actually called this function or this allocation 100,000 times at this position. Or these are actually all temporary allocations. Maybe you want to get rid of that. So I thought about that for a long, long time and finally came up with a solution called Heaptrack. It's an open source tool. You can get it on KDE Git, which is nowadays also being mirrored on GitHub. And you just run your application through Heaptrack, and it does its thing. It should be faster than Massive. And then you can visualize the results. I won't do the live coding here, but if you want to see it, do hunt me down and I'll show it to you. The analysis part then is pretty cool as well. I'm in the process of working on the UI. You can generate Massive files, which you can then visualize in Massive Visualize if you really want to. But that's not really fun because it takes a long time to generate the very, very inefficient Massive format. So if you want to use my Heaptrack format directly, use Heaptrack GUI, and that directly gives you the number of allocations that have been done at a given code point, the peak memory allocation that resulted at this point. You get the number of leaked bytes. So essentially, once you stop the process, what hasn't been freed. And then you can measure throughput as well. So allocated is just the bytes allocated in total, ignoring any deallocation or anything like that. And this is all with stack traces for every single allocation you do. And it's still faster than Massive. The thing is, I stand on the shoulders of giants there. I'll get to that. I did not write the stack unwinder to do that. You can both have a bottom-up and top-down view, which is sometimes useful. More importantly, you still have the same visualization you know from Massive Visualizer. So these stacked bar charts where the red one is the total amount of memory being used, and below that you see the top allocating functions. Essentially, you can hover it and get a tooltip, and I will add all the interactive features as well, so you can jump to a call stack and get more information out of it. But as I said, Heaptrack gives you more than just pure number of allocations, right? Or allocated bytes. It also counts how many allocations you're doing. Here you see these nice spikes where tons of allocations take place. This is actually the spell checker being used in the Kate editor that is very inefficient when it comes to allocations. And you also track the throughput. So again, the first spike here is the spell checker. The second one is Intel's graphics driver, which allocates a bunch of memory, but that's probably fine. But if you want to check that, Heaptrack gives you all the data at your hands. And also something that I've been working on recently is adding a so-called flame graph visualization. It's been invented by Brendan Gregg, very smart guy in the performance area. And this one is really, really neat. The width of each bar here gives you the cost. So the wider something is, the more it spends, or here it's the number of allocations, so the more allocations it triggers. And this way you can easily grasp a very complex call stack tree and just find hotspots in your code that you would not expect to be there. So I really invite you all to try it out. It's a very useful thing. One thing that I haven't yet added to the Heaptrack GUI, but I plan it's super simple to do, is getting a histogram. So in the sense of what sizes have been requested by your application and how often. And here, this is a very sad bar chart for me, or histogram, because this is every typical Qt application. Qt uses its own QString string class, which is not small string optimized. And you see thousands upon thousands. I mean, someone counted in the Qt application, Qt community. I think he said something like 80% or 60% of the allocations that a Qt application does normally are strings below, 5 chars or 6 chars or something like that. It's silly, but that's the case here. And Heaptrack, again, finds these things and can give you all the data you need, and then you can actually go in and maybe fix it, right? And we do plan to fix this for Qt 6, by the way. So how do I do it? I said already, I'm standing on the shoulders of giants. First thing first, this is for Linux only, because this is what I use to debug and profile and make things faster. At KDAP, I often have to work on Windows Qt apps as well, but because it's cross-platform, I can just compile the stuff on Linux, make it faster, and it will automatically be faster on Microsoft as well. So the first trick that is Linux specific is the LD preload trick. So you can just inject arbitrary code into your application before you start it. Heaptrack also allows you to runtime attach to an application that is running, something that Massive is not able to do because it cannot magically take the executable, inject it into the VM and then run from there, right? But here I asked on Stack Overflow for the magic to do, and someone showed me the ELF code to do it, and it actually works, which is pretty cool. So you can, after 10 hours, inject to your application, see who is triggering this memory increase, and then visualize it later on. It works. It's pretty cool. Lib-unwind is what I'm using to grab the backtraces. It's an amazing library, lots of arcane magic in there, and it's super, super fast. I mean, I can track millions of call stacks in seconds, and it doesn't have that much overhead. But if you try this out, do build lib-unwind from Git, because there have been some performance optimizations, and most Linux distributions ship a very old version of it. And if I profile Heaptrack itself, I see some spots in lib-unwind which I hope to optimize in the future as well. Then there is lib-backtrace. So lib-unwind gives me instruction pointers, and lib-backtrace I can then use to translate that to basically from the dwarf data to get function names and line numbers and files and stuff like that. So again, this is not my magic code. This is existing code that I thankfully can use. And then, the Heaptrack GUI is what you use to actually visualize the stuff. Installing Heaptrack is pretty simple. Check it out, run the CMake stuff, what you would always do. Don't forget to enable optimizations, so you should probably pass -d CMake build type equals rel with deb-info or release, because otherwise it's going to be slow, right? It's a profiler. You better install it with optimizations enabled. And so to wrap up, the good thing is it's very usable. It's often much faster, especially on embedded devices, than Massive. You get tons of data out of it, much more than you would ever get from Massive. And it's also the foundation for more tools in the future. I really plan to add features to track the pthread API to measure log contention, for example. It should be trivial now. The bad thing is that my UI part isn't finished yet. There's some things that I really want to fix. Thankfully, KDAP is now sponsoring me for a few days to work on that full time. So over the next months, you will see something there. And I think that more people should actually start using it because it's very damn useful. And the ugly part is, again, yeah, it's Linux specific. I saw someone adding a Win Heaptrack on GitHub without telling me. He used some other technique there to generate the same file format that I use, and then you can use Heaptrack GUI and get the same thing there. And yeah, if you want to track stack memory, use Massive. I don't know any other tool that does that. Thanks.